you are working on this line, and you have, if you want to calculate the real operating reactance for a ladle furnace, you must use this line. There's no cold steel in it. If you start an electric arc furnace, you start here, and they are going this. But in the ladle furnace, there's always, you have slack on it. There's a smooth operation, and you see that the maximum ratio of operating against short circuit reactance is 10%.
This is
IAF, start melting, main melting,
okay,
with cold scrap in it, and you know the different periods of the electric arc furnace is. Start. The boiling period is if you have scrap, cold scrap, and you bore holes in it, and the electrodes are moving down. The end of the boiling period is if the electrodes are down and you get here molten bath, this is liquid steel. This is the end of boiling. And the main melting period is as long as you have cold scrap at the board. And the end of the main melting you may have scrap here. And the arc are burning on liquid steel. And if the scrap is gone, the main melting period is at the end. And you know forming slag? Well, this is a forming slag. The forming slag can, a DC furnace, 1 meter forming slag. The slag is flowing out. Yes? Okay. And this is from Krüger. For several years we tried to make a control of forming slag. This is not easy. But this is the forming slack operation. Okay? And this forming slack operation is typical for ladle furnace operation. This. A smooth electric, very smooth and silent. Sometimes you cannot hear something. Okay? Okay, okay. Now we have 10 o'clock. We are waiting for coffee, yes? Am I correct?
Yes.
More questions to your construction. You have another construction?
It is fast. Is it possible for the?
For ladle furnace.
Is it possible? Essay here.
What?
So much the arc furnace.
I didn't understand in my head.
Same like
These are typical values for ladle furnace. You can also have systems, a small electric arc furnace, ARF, a very small, with 15 or 20 tons, may have this value.
Yeah.
So depending from the size
Yeah.
of the system, on the volume of the system.
Okay.
Well, this is a very good, I think, a very good morning for you, yes? Yeah?
Yeah.
With your construction? Did you make this construction?
This one?
Yeah?
No, Mr. Ong.
Mr. Ayon.
그 SF거든. 근데 여기 데비에이션 차이가 좀 많이 난다면서.
네. 그리고
한번 보자고.
Well, we have
제일
enough time to discuss so many construction as you want.
어차피 똑같은 개념이니까.
네.
이것도 또 삼각형 트라이앵글 구조잖아.
네.
그러니까 똑같은 구조니까 여기도 이제 다르게 튜브로 돼 있잖아요.
네.
한번 생각을 해보면 되지.
Is it also in ladle furnace?
No. This submerged arc furnace.
What?
Submerged arc furnace. We have ladle and this is coal.
Yeah.
Coals and
This is not a steel furnace.
Yeah.
Yeah.
The other, yeah.
It's a chemical
Yeah.
furnace. Aha. Yes. You can use it also for chemical operation.
Yeah.
Yeah, reduction furnace. Yeah, to make special to reduce special ore. Yeah, as a reduced furnace. But you know, if you have a reduction furnace, there's no open arc.
Yeah.
The arc is covered.
Yeah.
We are covered with slag.
Yeah.
You cannot see the arc,
Yeah.
and nobody knows exactly what happens inside the furnace. Yeah, we say this is a reduction furnace for reduction processes. If you will make, I think, you can also use this kind of construction for making steel from iron ore. We say this is direct reduction. They made attempts in Germany, a direct reduction of iron ore with this construction, but it was too expensive for using electric energy, and therefore they use gas energy for reduction. Yeah? And you can also make silicium by this.
Yeah.
If you have silicium, it's very expensive. From silicium dioxide to reduction to silicium. It's very, very, I think, 13,500 kilowatt-stunden per ton, which uses very much energy to make silicium, clean silicium for electronic components. But you can use this construction. There's no problem.
Manganum.
Manganum. You have ore in your country?
Yeah, we have some small size of power plant.
Yeah. Okay. We do not know what happens inside the system.
Yeah.
Yeah. If this is the furnace, what happens here? There are electric lines directly, and if you have a bad construction, the power is moving up, and under the roof you have too much temperature.
The upper side is warm.
Yeah. Maybe that the current is flowing over the steel system may flow back. Maybe, I do not know. You can use it. You can use it for construction of electric reduction furnaces.
Yeah, I think reaction furnace and EAF and ERF is same.
The same
structure and construction.
Yeah, the structure of electric energy is the same.
Yeah.
We also have in Germany they use for reduction furnaces, reduction electric arc furnaces, these constructions. Yeah, where we have three two-phase transformers around the vessel, and this is typical, especially if they're made carbide. Yeah, in Germany they use it. Therefore, this is called Knapsack connection. But and I told you that they put these transformers to one side, and this construction was also used for electric arc furnace for steel making. And this system, you see that the connection between delta and star is at the electrode holder. And I told you about this. These have very few reactance of 1.5 millions.
Yeah.
This is very few. But this did not work very good. Oh, he wanted to come at 10 o'clock. We now make a little short break, yes?
Yeah.
A very good lesson today. It was very good. Do you have more examples?
Example, we can please comment to me the other reduction furnace
Yeah.
structure and deviation is some problem.
Yeah. We can discuss. Let's discuss after our break
Okay.
later.